So today we're going to talk about the first part of kinetic molecular theory and Dalton's law of partial pressure. We're going to look at temperature conversions. So there are two temperature scales commonly used in science, and these are Celsius and Kelvin. Kelvin scale begins at absolute zero. An absolute zero is the absolute lowest temperature at which particles would have zero kinetic energy. By extension, particles would have zero pressure and zero volume. So if our gas isn't moving around at absolute zero, then we have zero pressure and zero volume. 0 degrees Celsius is equal to 273 Kelvin. 0 degrees Celsius does not correspond to zero average kinetic energy, zero pressure, or zero volume, as 0 Kelvin does. All gas law calculations must be performed with Kelvin temperatures, meaning that we are going to have to convert from Celsius to Kelvin. And it's easy how we do this. We take Celsius plus 273, and that'll equal our new Kelvin temperature. Now we are going to look at some conversion practice. So what is the temperature of gas in Kelvin at 95.7 degrees Celsius? We're going to use our equation Celsius temperature plus 273 to get our new Kelvin. So 95.7 plus 253 equals 368.7 Kelvin. We're going to keep our same decimal place because we want to keep our significant figures. So what is the temperature of gas in Celsius at 25 degrees Kelvin? So if we use the same equation, we know temperature Celsius plus 273 equals 25 Kelvin. So to get temperature Celsius by itself, we will subtract 273 from both sides, leaving Celsius by itself. So we have 25 minus 273, and that equals negative 248. Once again, we're keeping the same places of decimals as our starting temperature to preserve our significant figures.